So, one of the largest group of anxiolytic drugs that have been used in the past as well as are still in use today are a group of drugs that we call sedative hypnotic anxiolytics. So the first drug that was marketed and was commercially successful as an anxiolytic was called Quanil, which was a mipropamate drug. So this was an early non-barbiturate anxiolytic. And so this drug was very popular because it was less addictive than other anxiolytic drugs, but it still has a very narrow safety margin. And it was found to be an anxiolytic through sedation, but it also has a very high abuse potential. So that's a drug that is not prescribed as much anymore, but was very popular. But it was also kind of found to not be as great because of the type of drug it was, because it was the mipropamate drug. So instead, two different groups or families of drugs became very popular, and those would be barbiturates and benzodiazepines. So the treatment for anxiety has improved markedly with the development of these two drugs in the 20th century. So when we talk about barbiturates, then these are considered primarily sedative hypnotic drugs, a little bit more sedative than hypnotic. And benzodiazepines, sometimes abbreviated as BZD, are one of the first specific anxiolytic drugs. So while we have barbiturates and they're used for anxiolytic effects, benzodiazepines themselves were created to be anxiolytic drugs. So both of these types of drugs are also effective anticonvulsants, so you'll also see them widely used in epilepsy. It's also with these drugs that we would see a lot of ads. This is like in the 50s, just a nice ad for one of the drugs. You don't need to know about it, but I thought it was interesting that they, even back then, they had ads for anxiolytic drugs. So we're going to talk about barbiturates and benzodiazepines a little bit separately. So first with barbiturates. So the effects of barbiturates is that they're anxiolytic and tranquilizing at low doses. So what we see is a lot of that sedating effect. So we see the sedating and soporific at moderate doses, and work as anesthetic drugs at high doses. So here you can see a graph of things. So on the x-axis we have an increasing dose. So a dose of 0 would be over here, and then a high dose over here. And then on the y-axis is amount of consciousness. And you can see that as you increase the dose, consciousness decreases. So there's a large negative correlation with dose and amount of consciousness. So at a very low dose, people can be still be nice and alert. This would be a close to 0 dose. At kind of a low but moderate dose, we see that relief from anxiety. And then the more of a dose, then we see a sedation, a little more, and people will actually fall asleep. And then we can see how a larger dose can be used as general anesthesia. But if we give too much of the barbiturates, we see coma and even death. So much like alcohol, then barbiturates have a relatively narrow safety margin, and the risk of coma and death at doses above the therapeutic dose is very worrying for a lot of people. And like a lot of drugs, then barbiturates do have a very high potential for abuse. So in addition to accidental risk of the barbiturates themselves, an overdose of barbiturates is a common means of suicide. So barbiturates were the cause of several high-profile deaths in the 50s and 60s. So this would include Marilyn Monroe, Jimi Hendrix, Judy Garland, and Eddie Sedgwick. So you might have heard of some of their suicides, and that was via an overdose of barbiturates. And so you can kind of see why barbiturates aren't necessarily they're not the go-to for many doctors nowadays to prescribe for anxiety. Now, the other sedative hypnotic drug would be benzodiazepines. And so when we're talking about benzodiazepines and the history behind that, then we've got to talk about this dude, Leo Sternbach. He was in the Roche labs. And what Sternbach did was he studied the substituted tricyclic coloring agents for psychoactivity. And he determined midway through the project that there was a synthesis error and shelved the remaining untested drugs. So chlorodiazepoxide was retested by a co-worker who was cleaning out the shelves and found to have a pronounced effect as an anxiolytic and relaxant. And so we actually found that there was a huge commercial success of diazepam, which is known as Valium. That's its common name. And so, as we see with a lot of science, mistakes are sometimes the biggest breakthroughs. So it's pretty exciting that, it didn't do what he wanted, so he shelved it. And then a long time later, it turns out the drugs did have an effect, but it was just an effect that he wasn't originally looking for. So now let's talk about the receptor that benzodiazepine works on. So benzodiazepines are allosteric modulators at the GABA A receptor. So benzodiazepine site on GABA A, so that's you can see the site right here, is often referred to as the benzodiazepine receptor. Okay, so in some papers, you're going to notice that the literature describing the effects of benzos can be very confusing because they'll talk about the benzo receptor, and what they're talking about is the GABA A receptor and the benzo site on that receptor. And so there's many types of interactions at the receptor site. So it is an agonist, so it's an allosteric modulator of GABA A. It's a partial agonist. It's an antagonist, inversive agonist, which would be a negative allosteric modulator of GABA A. So you can see how there's a lot of different interactions that can actually happen at the benzodiazepine receptor site. So the agonist binding at the site are positive allosteric modulators of GABA A, while the inverse agonists at the benzo site are negative. Okay, so agonist binding are positive allosteric, and the inverse agonists are the negative allosteric. I hope that makes sense. So what about the sensitivity of benzo to modulate GABA A? So classic benzodiazepines act as positive allosteric modulators of GABA A, and the binding increases the response of the channel to lower concentrations of GABA. So benzos increase the frequency of the channel opening. Unlike barbiturates, the benzos do not have a GABA mimetic effect. In other words, it doesn't mimic GABA, it has its own effect. So benzos are less toxic than barbiturates due to their effect on open probability rather than open duration. So they change whether or not the receptor opens, not the amount of time it stays open. So by prolonging the opening time in barbiturates, it can exert a GABA mimic action at high enough doses that leads to those toxic effects. Whereas the benzos only increase the probability of it opening or not, so it doesn't have the capacity to open the channels in absence of GABA. It just means that when GABA is there, it's more likely to open. So the benzo site has for many years been considered an orphan receptor. So the existence of a natural ligand for the benzo site is proposed. So sometimes you'll hear it referred to as nature's Valium, and it's highly sought. And several compounds have been identified that will bind to the benzo site. So not just benzodiazepine itself binds there, but also other compounds can. And so these compounds will be called endozipines. Okay, so if you see that term, that just means it's a compound that binds at the benzo site. So we also have beta carbolines, which are small molecule inverse agonists at the benzo site. So remember, that would then be that would have the that's where we would see the negative allosteric modulators, right? And so then here's just 3 examples of those beta carbolines. And then diazepam binding inhibitor, or DBI, is a protein inverse agonist at the benzo site. So again, it's going to have the same effect as these beta carbolines. So the benzo agonists and inverse agonists, again, they're going to have different effects. So the benzo site of the GABA A is able to elicit both a positive and negative allosteric modulation of GABA activity. So again, the negative allosteric modulators will exert biological effects as the inverse agonists of the benzo site. So the inverse agonists bind and exert biological effects that is opposite of the agonist. So you can see here, how we have the inverse and then the positive agonist, right? So endozipine agonism, we should probably talk about that. So to date, most proposed endozipines function as inverse agonists at the benzo site. So we call them anxiogenic. And since the natural role of the endozipines is as negative allosteric modulators of GABA A rather than positive, it helps to make benzo terminology even more confusing, because that's what we all need. In animal studies, then, endozipines increase agitation, increase distress vocalizations, and increase aggressive models. In other words, we can use them to induce anxiety-like behaviors, right? And that's why we call it an anxiogenic. In human volunteers, then endozipines administration will increase muscle tension, autonomic hyperactivation, and extreme apprehension. So again, very similar to what we see in people diagnosed with anxiety. So the function of the endozipines support the model that the benzo receptor site plays a natural role in angiogenesis. So benzo drugs may in fact antagonize endozapine-induced anxiety. So effectively, benzo drugs are positive allosteric modulators, making them inverse agonists at the benzo site, while the negative allosteric modulators modulation by endozapines is agonism of the benzo site. In other words, drugs that we give people counteract this. They're the opposite of this. Okay, that's what it's saying. So, what's some evidence for endozapines in anxiety? So, to date, there's little evidence has been presented for a natural role of endozapines in anxiety disorders. And there was a backlash against the commercial success of benzos. So Valium was the top-selling drug from 1968 to 1982. But the British government sued Roche in 1973 for compensation for the massive public cost of Valium prescriptions. So sales of benzodiazepines are increasing in geometrical rather than arithmetical progression, and if the trend continues, total tranquilization of the population will soon be achieved. In other words, they're saying people were being prescribed to them way too often, way too high of rates, and it wasn't helping people. So the medial portrayal of the medicalization and tranquilization of everyday life in society really brought down the kind of reputation of benzos. And as a result of this lawsuit, there was a £4 million settlement to the NHS. So in the US, the FDA classifies benzos as a Schedule 4 controlled substance due to the high abuse potential. So again, this is why you'll see that they're not as prescribed as they used to be, and they're definitely not going to be the very first choice for someone that's first diagnosed with anxiety.